get into the big topic of open source, something that we actually say.
This is so awesome.
We are an open culture that believes in importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift Expert live stream. I would introduce you, Christian, but like since you're on the intro video, I feel like no introduction is really needed. But like for those who maybe don't know you, why don't you give a quick rundown of who you are?
Actually, when the intro was going on, I'm like, oh wow, they still have my video. So So like for those that don't know, actually, my name is Christian Hernandez. I'm currently working at Isovalent Cisco. But before then, I was at Red Hat for a very long time. That's how I know Jonny. That's how I know a lot of the people. I was the GitOps kingpin, as you see here, as I put in there, right? Still, so I was big in the Argo ecosystem. Still big. Wrote a book about it. I was actually still contributing. That's the great thing about open source, right? No matter like where you work, you're still like kind of connected to the original people there. So I'm no stranger to this show or any other show on Red Hat.
Yeah, I think you're one of the OGs too, right? Like you. Yeah. Back when like we were setting up all the, I came into it a little bit later, but like back when all of the live streams were getting stood up, you did part of like some of the original early series, right? Yeah.
Yeah, part of the original lineup as I guess, so to speak.
Nice.
And that was it's kind of cool to see it like keep going, right? Even after like people have moved and like different things there. So that's well, I was part of that original lineup. Yeah,
nice. Yeah, it's been it's been fun. Obviously, like you've been a part of this. Like it's chaotic sometimes when you're trying to like wrangle in guests and stuff like that. But yeah.
For sure.
It's been cool trying to get everything, and like I mean, obviously, like the amount of streams that we've done at this point, and like the amount of just people coming on, and we get to learn new stuff. And like with the stuff that you're doing with Isovalent, you get to come on and show off new stuff, which is pretty cool. So I'm glad you reached out to us and we were able to hook this up and get this going. So for some top of mind, before I jump into the top of mind, Sully won't be here today. He has some big time work stuff that he's got to do, but he should be back next week. We don't have a topic yet, but it might be. I think we're gonna jump into the start from zero. Like literally, I'm a new person. How do I get a developer's account? How do I start at zero and then get to hero? And so we'll figure that out. And then as we get closer to the stream, I'll have it scheduled, and you should see it on YouTube and LinkedIn and all that stuff. But yeah, like I said, nothing really big on the top of mind. It's actually been Christian and I were talking about this in a pre-show where it's been pretty quiet across the world. It seems like, which is
quiet in tech. So,
very, very strange. So with that, Christian, do you want to go ahead and kick it off?
No, I'll kick it off. I'll actually also share my screen. Probably where is it here? I always get that one. I have to share like multiple screens, so I might come off and on here. But I'll queue you up. It's all right. Like we're all good.
Yeah, just let me know.
Can you see that? Yeah, you see the intro slide? All right, cool. Yeah,
very nice.
Very. Shout out to actually our designers, right? In the world of AI, we actually have cool designers still on staff. So what I want to talk about today is, and the reason why I came on the Ask an OpenShift Expert here is that because I'm usually doing like CI/CD and application deployments, right? But I'm actually been part of something at Isovalent that we've been developing called Isopcap, right? And Isopcap, and as the name indicates, there's a PCAP is really talking about packet capture and packet capturing for triage on Kubernetes, right? On OpenShift, right? Which we'll go over in a second right here. But to kind of just step back a little bit, right? Talking about Kubernetes and OpenShift, but in Kubernetes in general, right? Like the Kubernetes will tell you something has failed, but like what actually happened when that failure happened, right? So like what happened on the wire when something didn't go right, And really, packet capture and network packet capture has long been like the standard troubleshooting language for like network teams, platform, application, and like even security teams. When like logs, metrics, traces, and flow records don't like fully explain what happened, or like doesn't really show you what happened, a PCAP file often does. And like on the physical network, right, like more like in like a traditional workflow, the workflow has always been familiar, right? Capture traffic from a known endpoint, right? You know, you log into a server, or you have like a network capture, you know, device there. Like you log in and you capture traffic from a known endpoint, export the trace, analyze it in Wireshark, right? It's been kind of like bread and butter. It's been kind of like the standard operating procedure for triage. But in the Kubernetes world, workloads move, right? Nodes may be managed by a cloud provider. Traffic may live on a primary or secondary interface on a pod. You know, now pods nowadays can have multiple interfaces, and it's very dynamic, right? Kubernetes is very dynamic. And when you need to capture something, right? When you get down to it, when you get down to the triage phase of when you need a capture request often crosses team boundaries in a Kubernetes environment, a cloud native environment. And like that old access pattern, right, don't map cleanly to cloud native operations, right? So all that is kind of like a big intro to explain why we introduced Isopcap as part of the Isovalent networking for Kubernetes, right? It's a feature of Isovalent networking for Kubernetes, which is based on Cilium. And so what is Isopcap, right? So as the name suggests, right, is a packet capture tool that is Kubernetes native. So Isopcap is built around really a simple idea. A packet capture should behave just like any other Kubernetes native operation, right? So the user expresses intent via Kubernetes custom resource. And it brings basic network operation function into a more cloud native friendly workload. So it gives kind of platform teams a declarative way to capture a pod traffic using Kubernetes custom resources. So in the end, you still get like a standard PCAP files, so that like, you know, network security or application teams can analyze with familiar tools, right? So like Wireshark or TCP dump, right? So we're not changing anything. We're just in terms of like packet capturing and actually generating these files. We're just making it more cloud native friendly to retrieve those files, right? And so I do want to note here, there's a note there, the bullet point. I do want to call out that it's CNI independent, right? You know, I'm at Isovalent. You know, we do everything with Cilium. You asked me which CNI to use. I'm going to say Cilium. But with Isopcap, that's all independent, right? We're just doing packet capture, so you don't have to be using any specific CNI. We're able to capture packets. Because it's at a very, very low level, right? We are able to capture packets no matter what CNI you're using. So, and I like to say that it's packet. What is Isopcap? It's a packet capture for now, right? Packet capture that is Kubernetes native, right? So instead of SSH, so you don't need to SSH into nodes. You don't need to install tools. You don't need to restart workloads. You don't need to add any sidecars, or you don't need to ask application teams to modify pod security policies. You don't need to do, I guess in OpenShift, you don't need to go like OC debug node and run TCP dump, right? All you need to do is run a packet capture resource, right? So basically, it allows you to do kind of, now that it's Kubernetes native, it allows you to do Kubernetes type thingies, right? Like filter by labels, which is actually very powerful, right? Because it comes back down to what we say in Isovalent, like identity aware workflows, right? So like we say like Cilium, when you're talking about like Cilium or like even Tetragon, but like just stick with Cilium, is like you have identity, you create a network policy that's identity aware, right? You're not really like targeting like IP addresses or anything in the traditional NetOps world, right? Like you're just doing it by identity. And same thing with packet capture, right? You just kind of do you filter by labels, or if you filter by identity. What's really even cool is like you can do trigger-based capturing, which I'll actually get a little deeper in a little bit. But you can like trigger packet captures during certain events, right? Which is actually really cool. From a high level, this is a high level architecture, right? Isopcap runs as a daemon set, so it's running on all nodes. And this Isopcap agent identifies matching pods on each node, right? So, and once it identifies a pod, it'll discover the relevant pod interfaces and then capture traffic from inside the pod's network namespace. So, so that's kind of like you don't have to like figure out where or like which interface or identify anything. You're just saying, here's a workload. Can you capture packets from there? Workflows. Oh, go ahead. Yeah.
Yeah, I'm just curious. So is it actually picking up right off the pod, or is it actually like I'm trying to think of the right networking nerd word here. Like, is it actually like going off of the vSwitch and siphoning off of the vSwitch, or is it just capturing directly? Like, you're basically saying, hey, go to like F0 on my pod and basically do a TCP dump off of that, or you know what I mean, or is it actually tapping into the line?
Yeah. No, it's doing it from the perspective of the pod.
Okay.
So in the pod's network namespace, right? So
okay.
From that perspective, yeah.
Gotcha.
And actually, that's a good segue, right, to like the actual packet flow, right? Because packet capture workflow it's almost like any other kind of workflow in Kubernetes, right? A user creates a packet capture custom resources, right? Submits it to Kubernetes. And then the Isopcap agent then does its discovery, right? Like it looks for the pods, it looks for those interfaces, and then it goes inside the pod's network's namespace and then does a packet capture. And then once it's done with the capture, and then we'll see in a minute what thresholds you can set and whatnot. But once it has that, it produces that pcap and G file plus some metadata that you can like port into things like Wireshark or TCP dump or any of those network analyzing tools that you're used to. Mm-hmm. And actually, so I'm gonna like interrupt my presentation because I have like a few more slides to go to, but I want to like drop into a quick demo just to kind of just see how it works, and then we'll dig deep into each component, right? And I was like doing a kind of like a real life simulation, right? Kind of based demo. So for example, like you have an application, right? And then like the application team is saying this application is dropping HTTP requests, and like users are reporting very high latency, right? Their traces, are showing like information, but they can't tell why, right? So like you see like high latency spikes, you're seeing dropping HTTP requests, but they see that in their tracing logs, but they don't know why, right? So they're asking, usually like this is kind of like the DevOps aspect. It's like, okay, well, like what's the platform team? Hey, can you help us debug this? Because we have no idea what's going on, right? And so let me, that's really cool. You can do a replace instead of like stop sharing, resharing. You can like actually replace. Sorry, I thought that was really cool. Technology, you gotta love it, right? So you should see my my demo screen, right? Do you see that?
Yep, I can see it. Yep.
All right, cool. So I have an OpenShift cluster here, version what is that? 4.22.9, right? I see that going on there. I'm running on a cluster, right? So this cluster has this is a single OpenShift node cluster running some workloads here. And I'm running as admin or cluster admin, but you just need access to your own pods, right? Like, so this isn't necessarily an admin task. It probably will be, in all situations, but you just, for me, I just need to be an admin to the namespaces that I'm capturing. So let's take a look at a packet capture, custom resources, right? So this here is pretty straightforward, right? So I'm going to select the application, right? So all pods in the default namespace that matches these labels, right? So app equals shop, right? And then pretty standard filters though. So TCP port 80, right? So give me TCP port 80. For those that are familiar with eBPF, this is like a standard eBPF filter. So if you are familiar with eBPF, this is kind of just standard. So max duration, right? I'm gonna do it for 30 seconds max, or until my file reaches 10 megabytes, right? And so just like any other Kubernetes custom resource, I capture that packet, create that that custom resource, and then I can watch the status here. So as you see here, it already captured 470 packets for 10 seconds, right? It's running on one node. If I had more nodes or a multi cluster node, it would only run on the nodes that the pod is running. If you have multiple pods on multiple nodes, it'll actually capture all of that traffic as well on all of those, right? And so that'll run for about 30 seconds here now, and now it's completed, right? And so once that's done, I can grab that PCAP file. So in a production like environment, right, like this will be like on a persistent volume, or it'll be like on a shared resource that gets copied over somewhere to a central location right here. But here I'm just going to use kubectl cp to like copy it off of the actual pod, off the actual agent there, as you see. And then I can just run TCP dump on it. From here on out, here is just a standard NetOps operation, right? I can actually run a TCP dump and check it out here. So here I can see things like there's the 200, there's the connections going, right? But as you remember, as our use case said, like the application teams is dropping HTTP requests, right? So and you can use TCP dump to look for the TCP reset a flag there on TCP dump, right? And as you can see here, there is a bunch of resets to that endpoint, right? So it's reaching an endpoint that's sending back TCP resets. Here, then I can just investigate that IP address. Maybe it's like an external IP address. Maybe it's a gateway, and one of its backends is faulty there. But at least it gives me a target to go look at, right? And for those of you that like, TCP dump's great, right? But like if you use something like Wireshark here, or like for me, I like using Termshark because I'm a command line junkie. You can actually like just import that in, and you can see all the, the green is good, right? Red is bad, right? I can see the TCP reset here. And then, using, my analyzer, I can actually go here and, look at frame by frame if you want, right? So it's just a standard. That's just to show it's a standard TCP, PCAP file that you can investigate with TCP dump or with like Wireshark. So that explains the dropping HTTP request, right? There's a faulty backend sending resets, right? But since it's always DNS, right? We always say it's DNS. It's worth checking out, right? Just to kind of see what may be the latency, right? Because that doesn't explain the latency, right? It just explains the drop request. So might as well look at DNS, right? It's always DNS's fault. I say it's always DNS, but very, very similar. Instead of filtering on port 80, I'm going to do on 53. UDP 53. Same workflow, right? So this is starting to become familiar workflow. For like the Kubernetes cloud native, you run you apply the packet capture, and that runs for about 30 seconds. Again, if this is running on one node, if it was running on multiple nodes, it would it's a daemon set, right? So it'll just like fire off on all nodes, on all relative nodes there.
So
done.
Let me just ask this. Yeah. So is it like your typical? I'm just thinking like deployment workflow of getting. So you have Isovalent installed, right? And then you would essentially install the daemon set or the deployment for the Isopcap thing, right?
Yeah.
Then at that point, it just kind of sits in your cluster. And then if you're like a project admin, or if you've got elevated privileges and you need to debug it, then this would just be a tool that you would have kind of sitting in your cluster. Or is this something that like what's the day-to-day on it? Or is it more of like a as needed? Is this something that you would use like on pretty consistently, I guess is what I'm asking?
Yeah. So it's run as a daemon set, right? So you install the Helm chart, and like the agents are just sitting there waiting to do something, right? So it's basically on your cluster sitting idle in case you want to do something.
Okay.
So again, the capture finished, right? So then again, copy that pcat file, run some TCP dump on it, and then to see that you see the application is making call to non-existent domain, right? So that explains the latency. So here it turned, so the idea here is that it turned it's slow and we're seeing weird things into like actually concrete data, right? So we say, here's an IP address of the faulty backend, and here you're making calls to a non-existent domain, no guesswork to be done there. You just kind of what is it? It's data based, right? Kind of triage,
Right
there. So if I go back, this is really cool that I can just like replace the window. It makes things a little easier.
There are some upsides to like the UI changes in Restream, but there are also a lot of like
they're also down.
things
They're little quirky things. Yeah, no, that's for sure. So there's a few type of captures you can do. We saw a couple of them this year. So there's the basic capture, is basically capture everything, right? So this is the basic capture, max duration 30 seconds, meaning capture all traffic. This will capture all traffic, kind of just dump. This is kind of like when you don't know what's going on, you want to just grab everything. We saw in the demo was the filtered capture, right? So the filtered capture is basically you filter on like protocol and port, and all of these have thresholds, right? You can have max duration, max size, right? You don't want like your file to be big. Here's this is really cool. What I really like is the triggered based capture, right? So you can start a capture, right, and then stop. Trigger to stop after a certain threshold, right? Like, hey, like the TCP reset, like, hey, I don't need 500 gigabytes of data. I don't need, I'm just trying to triage something really quick. Run this and then stop it as soon as you see 3 TCP resets, right? And then you can have things like a post trigger. Post trigger is cool. It's like, all right, hit the threshold and then add 5 seconds, right? So as you see 3 TCP resets, and then capture 5 more seconds, and then just give me that file.
Nice.
And then you can have a safety net, right? You can say max duration, like just never run longer than 5 megabytes. You can, but sometimes you also want to capture a specific event, right? And only that event. So you can actually have a pre-trigger. Pre-triggers are things like, right now we only support file watch. So this does actually require, like, if you want to do a pre-trigger, require something from your application teams. It's like your application teams are saying, hey, anytime we do X, something weird's going on, man. And then you say, all right, every time you do X, write this file. And as soon as you write that file, as soon as that application writes that file, it triggers a capture, right?
Oh, that's kind of dope.
Yeah. So then you can trigger a capture that way, and then you can actually then do both, right? Like, all right, have the application team trigger a capture, on their own, on their application side, right? Whenever they're doing whatever they're doing. And then anytime you see, again here, TCP reset 3 of those, capture it, right? So then you have like a kind of like a cool window of here's a pcat file of right before it happens and then right after it ends, and then you can kind of just see what happened in there, right? So in terms of like helping triage, like it helps, very, very DevOpsy, very cloud native type of way, right? Like this is DevOps in action, right? It's like, okay, hey, developer, you seeing weird, great, love to help you. Write this file whenever you do X. We'll trigger a capture and I'll investigate it for you. And so this is that's actually kind of cool with the triggered capture, right? Like you can actually start doing cool things there. We also support RSpan live streaming. So what this is, you can actually, instead of writing out a pcat file, you can actually just stream it and then you can just use Wireshark and you just connect directly to that socket, right? Like you can expose it via node port or like a port forwarding or whatever. So you can just like fire off a capture, do a port forward, connect your Wireshark into an RSpan socket there, and just watch it live stream, right? So you can actually watch the traffic go there. So
oh yeah.
So that's actually so. Go ahead. Sorry.
No, I'm sorry. I was just gonna say I think it's awesome because like like what you're doing here, you're making it look easy, right? And I mean I think having a config file, having a manifest where you can apply and say, hey, I want to do these. Here's the different like things that I want to do, right, with the tolerations and stuff like that. It looks awesome. But before you had this, right, it was a giant pain in the butt to try and figure this stuff out, right? Because you either had to, you had to release the permissions on your cluster, right? Or like give root level permissions on your cluster or on your nodes to be able to get to it. Or you just had to get really freaking hacky with it sometimes. And yeah, it's kind of nice to be able to just have a daemon set and then you just apply a manifest and then go review a file. I think it's pretty awesome.
Yeah, and then that's kind of like the idea behind it. We wanted to make it super really Kubernetes native, right? Or like kind of just YAML simple, right? Like it's like here, I wanted to here like just give me the pcap file, right? Like just like I understand, like I don't need like you don't want me to log into the node. That's I don't think anyone wants to log into a node anymore, right? Like the Hillary, like talk about it's like anytime her team needs to log into a node, right, for their cloud services, like it like fills out an incident report and like they have to track it. Like there's like legal ramifications of like I don't think anyone wants to log into a node anymore. And so like this is kind of easy where it's like I just need a pcap file, just trying to figure out what's going on, and it brings it more into like that collaborative aspect of it. So it's really really cool. So I do have, like anything, right, with Isovalent, we have a lab, right? So like encourage everyone to go and like get hands-on. So like get hands-on with it. Like literally this is a hands-on lab, like hands-on keyboard. You actually go through a lot of other stuff. Things like the target capture, you actually get to have an example of doing a target capture and a lot of the other cool stuff right there. And then you get those sweet internet points, right? You get a badge, right? Once you finish that, you get a cool badge. Actually, if anyone watching this here, if you're taking the lab and you get a badge, actually tag me, post it on LinkedIn and tag me, because I love hearing feedback. I actually built this lab. I'm no stranger to building labs, right? I did a lot of Argo CD labs back in the day. So I'd love to hear the feedback, and I'd love to hear you boasting about how you like Isopcap. So yeah. So kind of in general, in summary, right? So kind of what we've been kind of talking about, Jonny, like basically we're just modernizing packet capture, just bringing it into Kubernetes, making it easier for folks. Again, CNI independent, right? It doesn't really necessarily need Cilium, right? I will argue for Cilium always, but you don't need Cilium, right? Like you can actually start doing this today on any Kubernetes cluster. It automates, and it secures workloads, meaning like, again, we're just talking about, we don't want to log in. We don't want to give admin access. You don't want to run like a privileged pod, right? You don't want to do OCD big node, right? I don't want access to any sensitive data. So it actually makes it a little bit more secure. People are able to do the triage without elevating privileges. And then cross-team collaboration, right? Like we always love that in DevOps. We always for the longest time there always was that tension, right, with dev and operations, right? And then DevOps came along, making us work together, and this like actually makes it even work more closer together, because now we're bringing the NetOps and security folks into it, right? It's like, hey, yeah, you on the fringes, actually, you can help us out as well by getting them involved there. So yeah, that was kind of like go ahead.
I was going to say too, like when you're debugging something and you're trying to prove that it's the network, or you're trying to prove that it's a network level issue or whatever, right? It makes, you can actually capture traffic and review it and be like, hey, look, you can go back to your network team and be like, look, dude, you've got a DHCP server out there responding somewhere, or you've got you got DNS doing weird things that's resolving some like crazy things on the back end. So you know what I mean? So it's like you can actually be smarter about how you interact with your network team or with the teams that are outside of your immediate circle, and actually go with like data driven, like, hey, it's right here. Like you can actually see it dropping right here. Then help me.
Yeah, exactly. Well, like it prove that it is or isn't, right? Like, it's like sometimes, right? Like it's with back in my youth when I worked systems, right? We always used to say like, without the data, it's just a rumor, right? Like, hey, this is slow. It's like, okay, well, like that's just a rumor because like I where's the data? Like let's get down and actually see why it's slow, right? Why? So like you said, prove that it's the network or prove that it's not the network, right? Like it's like, hey. Sometimes you look at a packet capture and you're like, there's nothing wrong here. And then you have to go in deeper, right? You have to go in like, how does the disk look like? Is there like, CPU weirdness or, whatever, right? Like, there's a faulty hardware, right? Like you never know.
Exactly.
But you can at least prove out like, okay, like communication is working, cleanly, or it's not, right? Like you saw like in the demo, right? Like there's a TCP reset. Okay. Like, I can now then look at that endpoint and be like, okay, what's wrong with that endpoint? It actually helps you then in triage instead of like just second guessing work. So, and actually now you have an answer. Is like, is it DNS? Like, well, let me run a packet capture. They run a packet capture and see if it is DNS, right? Because it's we have that joke, but it's not always DNS. But like sometimes symptoms appear as if it's DNS. So
right.
Then, but you think at least now you can prove it out.
But it's usually DNS.
It's usually is DNS, yeah. DNS or Cloudflare, right? Like, there's like something, there's an outage somewhere right there, yeah.
Man, that reminds me. That reminds me of like when I was, before I came over to Red Hat. Like I used to work with this network guy, and it used to get under my skin so bad because he would just ask me all these like really silly questions. Like, did you do this? Did you do this? And ultimately what he was doing is he had a process, right? He had a flow that he went through in his mind of how he got from 0 to like, okay, now it's my it's time for me to pick it up. And so like once I kind of caught on to that, it actually made me like, I would troubleshoot all the basic things first, right? Or all the things I knew he was going to ask. So I would just go through and I'm like, hey, like, I'm not going to say his name because if he's watching, then he'll know exactly what I'm talking about. But like, I'd be like, hey dude, just so you know, like I'm seeing this issue. Here's the symptom that I'm seeing. Here's what I've done. Here's how it proves it's not me. I don't know where the break is. You know what I mean? And then that's when he would be like, oh, okay. And then he would just be much more, I can jump right in right here because now you've gone over everything I'm going to ask you. So I feel like you can actually provide this.
Yeah, you can actually provide that. You can have to say, it's always helpful when you say, this is what I tried. And this is what I saw. I need help figuring out, right? And then this, like you said, this could be part of it, right? Like I say, hey, I ran a packet capture. It looks clean to me, or like, hey, I'm seeing TCP resets, or whatever. You actually have the steps, right? A lot of that troubleshooting. Well, a lot of that troubleshooting, then like they tell you, go through the OSI model, right? Like, is it plugged in, right? Like, that's sort of, is it on?
Did you right click it?
Yeah, exactly. Yeah, like, can you run a ping, right? Like it. But I mean, a lot of times in a Kubernetes environment, like some of those steps is like kind of hard to do without actually, like I said, you're crossing team boundaries, right? So hopefully this tool that I've been involved with, in this product that I've been involved with, helps bring a little bit of that troubleshooting, eases it up a little bit.
Yeah, I think it will. It's awesome.
Cool. Yeah, that's all I had for Isopcap. I was running it on OpenShift, right? Like I said, in any CNI works. So yeah, if there's any questions for anyone.
Yeah, it's actually been very quiet.
Is our Hope 9 even on?
I don't know. Like I was just looking to see because he's normally chiming in. I did want to ask you, like, have you run this with like KubeVirt or in my world it's OpenShift virtualization, but have you run it like with KubeVirt or like it's virtual machines at all, or is it all just been basically like Kubernetes applications?
Yeah, so I've run it against OpenShift virtualization, right? And so I mean that's what I run. And since the VM is nothing more than it's just running in a pod.
Pod,
It'll capture that. It'll capture that traffic. Yeah.
Okay.
It'll even capture things like if you're running like Multis or SRIOV, right? Like if you're running like that network card, right? That splits up your network. It'll capture those. It runs at a very, very low level, so it's able to capture those packets. Yeah. So
nice.
Yeah.
So,
especially
so
like now, like OpenShift virtualization, you're bringing in like different workloads there. It becomes actually even more powerful tool once you start like layering on those things, for sure.
Yeah, that's kind of like, I think where I'm like in my mind kind of seeing where it's going is like, you have a pod and maybe it's multi-homed, right? So you've got maybe a pod that's on like a UDN, and then a pod that's on maybe another UDN or some other Multis type network. Can you capture both of those, or do you like? Would you have to create a CRD for each one of those interfaces, or are you able to like, can you splat it? You know what I mean? Can you do like ETH star?
Yeah. Well, so you can capture, you're capturing the entire network namespace of the pod, right? So by default, it'll capture everything that's happening on the network for that pod. But you can actually even filter it even further down. So like you said, ETH, like, you can actually say, capture traffic on the spot, but maybe you don't want to capture, like you said, it's multi-home. So like maybe it's like it's on a network and there's a problem only on one of the network. You can say ETH0, only capture that, or ETH1, or like there's multiple, like give me ETH1, 2, and 3, right? Or ETH splat, like you said, like you can filter those down, right? So you can actually go specifically down to like the actual interface, right? The virtual interface, like on the pod. Yeah, you can definitely do that.
Yeah, that's awesome. Yeah, that's thinking through virtualization, because that's where you're going to see it the most, right? It's when, especially you start attaching multiple networks to it, and then trying to figure out like where is this thing actually dying at and stuff like that. So then, with the eventing and things like that, do you? I guess something with triggers it, and then like, can you have it where, like from an SRE perspective, right? Like where maybe it's, you've got an alert that sets up like, hey, this pod crashed 3 times in the last 5 minutes or whatever. And then once that alert kicks off, then have you seen it to where you guys are doing like an automatic capture on something like what? I'm just thinking like an event, right? Like, so pod crashes, triggers an alert. That alert says, okay, bam, now that I'm firing off, I'm going to start capturing. And then, you know what I mean? And then like just this whole like kind of troubleshooting SRE thingy pipeline kind of deal. So I've seen it, since it's just another Kubernetes resource, you can definitely like tie it into automation, right? Like you said, like your alerting system or something, it says, okay, like, something happened. I'm going to create a packet capture and capture that, when, the pod restarts or something like that. So you can actually eventually, you can tie it into that, like that workflow. That workflow is actually the idea behind it, right? Like helping the triage or helping like automate some of the things like, okay, we need to collect as much data as possible, right? We also have, so you can't do this today, but we actually were having, the product team, we were having a discussion about creating a packet capture, but like not like it just sitting there, right? Until something happens, right? So like I gave you the example. So like here, this trigger here, let me go back one more. That trigger here, that TCP reset, that's a stop trigger. We were talking about making that a start trigger, meaning that once you see 3 TCP resets, do a fire off at there. So we were actually talking about like instead of it being file based, because right now I don't have a YAML right now to show you the file, because right now the only way to trigger one is to write a file. But it would be cool to like have one fire off when an event happens, right? So that's something we're discussing in terms of like, outside of like, CI automation workflows. Because a lot of the times, I don't know if you ever been in a situation, John, I'm pretty sure you have, where like you're trying to triage something, but you just can't catch it when it's going on, right? Oh my God, yes.
Right. Like I've been in many of those situations where application, like, back in the day, the phone rings, right? Like you pick it up, the, app developers like, hey, blah, 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 what's going on? you go and you look, you're like, well, I don't see anything. He goes, well, it's not happening anymore. I'm like, oh crap, okay. Like, you know, when you go look, it's not happening, right? That was kind of like what I was bringing up to the product team, where it's like there's those situations where it's like I want to see it happens like when it happens, and sometimes I can't get there in time, and so that would be kind of like a cool use case. It's not there today. You can kind of get there with like, you know, doing the file-based trigger, and then having kind of like the stop here, so you can kind of get like a cool window now, but that would be cool. So. But but like to your original question, you can do that today, right? It's just a Kubernetes object, right? So like if you have automation built around Kubernetes, you can have that automation trigger packet capture.
Okay, gotcha. That's awesome. Yeah, it goes back to like the whole like the example you used earlier about like, oh, this is slow, right? Like it's super objective, right? Yeah, where you're like, or not subjective, right? Or wait, no, I'm confused.
Subjective,
subjective. Where it's like, to me, it's like, well, this is fine, but then to you, you're like, no, dude, I'm trying to do XYZ operations, and like it normally goes this, and it's being able to like, all right, hey, cool. Well, now you can actually capture it in the moment, right? Instead of, because I've definitely, that's been my thing, where it's like, hey, this is really slow, or this is misbehaving, and then you go and you're like, you're watching and they're like, well, okay, of course it's not doing it now because of the proximity fix, right? You're there and
exactly.
You bullet it into working.
I walked in and it started working. Yeah. It's you're right. Like and it is also, like you said, it's subjective, right? Like it's like you say, oh, like it's slow, or the network's slow. It's like you look and you can actually have data. It's like, well, you know, we're pushing, you know, XYZ through the wire. What's your expectation? At least the conversation changes, right? Like you have data. It's like, all right, so like that, to me, that's fine, but you're saying it's slow. Like, what's your expectation? So at least you have hard data and look at it, right? Like it's not based on like, you know, what you think something should be. It's like, well, I think it's fine, and the developer thinks it isn't. Okay, well, like, you know, here's the data, like, you know, at least you got a starting point now. It's like, you know, you can say, is that fine? And then, you know, developers say, no, I need XYZ, or just like, oh yeah, that is fine. Maybe it's something else, right? Like, you know, you can have conversations based on actual data.
Yeah, but you're also baselining what good looks like too, right? So like, if they're like, hey, this is exactly what it's supposed to look like, then you can take a capture over, you know, a period of time, and doing their thing, and you can like, hey, this is actually what good looks like, and then compare that to when they're saying it's bad, and it helps you kind of filter down what the actual issues are.
Exactly. It's like if you work with circuits, right? Like if you like bought like circuits, like they say like the 90 percentile, right? It's like, you know, here's the throughput we promise you 90% of the time, right? Like so if it falls under there, right, and you like, you know, you're like you said, like this is what good looks like. Like, well, during high traffic, you know, I'm down here, you know, 90% of the time I'm down here, and you promised up here, right? Like that's like you said, you established that baseline.
Yeah,
man, you're taking me back like way back.
Dude, I'm telling you, it's a lot of these tools, like it's funny, like I guess in my mind a long time ago when I, you know, first started learning about Kubernetes, you're like, oh man, this is going to change the way that we do everything. We're not even going to use a lot of these tools, like we're not going to use TCP dump anymore. And then here we are 10 years later, and it's like, all right, well, we're still using TCP dump, but we're using it in a different way. We're using Wireshark in a different way. It's the same, but it's different, but it's the same. You know,
it's different, but it's the same. Yeah. The more these things change, the more they say the same sort of thing, right? It's like you still need some of these lower level type of things. Well, I mean, just look at virtualization in general, right? Like we talk about Kubernetes, and we talk about, again, I'm a big, I came when I was at Red Hat, I was in the OpenShift business unit, right? Like I, helped build that. I love Kubernetes. I love OpenShift, but VMs aren't going anywhere. Like, like those workloads are you're always going to need VMs in your workloads. And like you said, it changes, right? Now you're running it on Kubernetes, but there's still like VMs, right? You still need things that VMs need in order to run. So that's also, look at virtualization, like things are changing, but they're staying the same at the same time.
Yeah, that's one. I'll be honest with you. Like when Kubernetes really started taking hold, right? Like when it really started getting teeth, I was like, all right, this might actually be a game changer. Like especially with the way that we're talking about stateful applications and stuff like that. It's like, okay, once we got away from like the stateless bit of Kubernetes and we started adding state with PVs and stuff like that, and like different storage providers, was like, okay, this could actually be a contender for like, not, I don't want to say displacing virtual machines, but like, at the same time, it's like, where do you need both? And then the answer is actually yes. Yeah, you do. Yeah,
actually you do. Yeah, actually, actually, very much so. Yeah, yeah.
Yeah, I think that the initial boom was like, okay, let's get off of VM and get into a container, and it's like, all right, well that worked out great. While I was in like obviously either in a single cloud or I was in on-prem or whatever. But as soon as I started having to like scale across multiple clouds or, like on-prem bare metal cloud, but it just doesn't make sense to maybe run the same infrastructure everywhere. And like, yeah, it does make sense to have VMs and containers. And sometimes you do need like deep persistence and stuff like that. So yeah, it's been kind of cool.
Yeah, it's been kind of cool. It's been kind of cool to see it, and I never thought I'd see the day of VMs evolving, but they're evolving now. Now they're in this different type of orchestrator of Kubernetes, right? But it's a lot of paradigms still have to exist, and so it's very interesting. Very interesting. Yeah, never thought I'd be back in my world of like networking and like securing networks and stuff like that. But here I am at Cisco.
Yeah.
Helping that for cloud native folks.
So let me ask you this: how's the atrophy been? Like kind of like recovering from the atrophy, coming from like OpenShift and GitOps, and then coming back into the network world. Like it's probably taking some like revamp, like
oh yeah,
warm up time, kind of like all right, subnetting. Like, okay, God,
for sure. Like well, like I was like taking a look, and I'm like, man, I used to be able to like subnet in my head, like building out networks, like you said, atrophy. It said, I'm like, oh man, like I need to remember these muscles a little bit, because like they're talking about like GRE VPNs and BGP and things. I'm like, I used to know this like really, really well, and like haven't touched it for a while. The atrophy, it's like it's like riding, getting back on a bike, right? Like you're all wobbly at first. You're like, okay, but after a while, like, yeah, I got this. I remember how to do this. Yeah, I remember how to do this.
Yeah, dude.
Because
I was a CCNP at one point. I actually was very strong in networking for a while, and then I just have not touched it in any like real way, and probably 8 years or whatever. And so like that atrophy is real. So like when Sully and I were talking about BGP, I'm like, I can see it in my head. Like I've got like the concepts down, but I know
the map and the concepts. Yeah, exactly.
Yeah. But right, man,
like,
it hurts.
Peers and like like what is the ID? What is okay? My peer, like I'm like, okay, like I remember this. Like you're like typing it. Okay, yeah, it's there. Yeah, because I was also like I think I was CCNA, right, routing and switching, and pre Kubernetes, right, like I was like building out data centers, right, for the company I used to be at before Red Hat. And yeah, I remember like doing those point-to-point connections and like wiring and subnetting and like keeping all that in your head. And then like you jump onto this like Kubernetes train, and then all of a sudden I'm back. I'm like, oh, okay. I kind of remember. Yeah, I remember this.
Like, dang, and then it's changed, right? Like with the way that like Cisco networking, especially like with Nexus and stuff like that, and then some of the other stuff that they're doing, like it's just gotten it's way better. But like back in the day, like troubleshooting used to be pretty linear. You could actually start like, where's my problem, and then work your way backwards from the problem. And I feel like, especially as a network, I don't want to say network guy, but like as a network manager or whatever, right? Whatever, I don't even know what they're called anymore, but like you can say, okay, look, you're not getting to this point, and you can actually start working your way backwards. And it was pretty easy to troubleshoot that. I would say, and then yeah, and then even like with system troubleshooting and stuff, it wasn't that bad. But now, like with Kubernetes and cloud in general, right? Well, like if you're trying to, is this a vSwitch issue? Is this an actual pod issue? Is this a storage thing? Like where is this actual fault at? And it's trying to find it. It's a needle in the haystack most of the time. So
yeah, it goes before. It's like you would say, is this a software or hardware issue? And like sometimes, like nowadays, it's like there's like a combination of all kinds of stuff, right? It's like hardware and it's software and hardware. The software running on the hardware. It's the application and the hardware, and that it's like you're like, oh, okay, like where are those mushy points? It's like when you mush two different color Play-Dohs together and you try to like pick it apart afterward, right? Like it starts being, you're like, oh, which which
Like, yep.
which one's
I
pink
messed
and
up.
which one's orange? I'm not sure. Yeah, I messed up. Yeah, I made a big mistake. You can't unplay-doh that.
Yeah, I'm sorry, kids. My bad. I did this.
Yeah, exactly. I'm sorry. Now you have gray.
Yeah, it's like and sometimes you get lucky and the cloud provider will have a node that just kind of craps itself without completely crapping itself, and so then you're debugging something just to realize like, oh, it couldn't migrate you off, so you actually just had to shut it down and let it force migrate off.
Yeah, exactly.
Yeah, go back to like the old school way of doing things, like just the ONOFF button and
yeah, exactly. Yeah,
Oh man,
like
so R9,
thank you. Yeah, what did our Open 9 say something? Oh, he's on.
No, he's here lurking in the background. So I was just gonna call him out for being here. So
there you go. Awesome.
Cool. So is there like what's next with this? Is it are you guys gonna put like a UI around it, or are you gonna do
so the idea is, so we have a UI for Isovalent networking for Kubernetes, or Sullivan, right? Like, so we have that UI already built. So we're just going to incorporate that into the UI. It's called Hubble, right? So so we're going to integrate it to Hubble, so that way, so that way we can have a UI and do all the UI things that you can with it. So that's kind of like the next step. What we're going to do is that we're actually actively working on that. So I think not the next release, but the release after, we're going to it's going to be integrated into the Isovalent UI.
Okay. Yeah, and if you haven't seen that Hubble UI, it is really well done. It's super clean. Like I think I've seen you and Dina both done a demo on it. It's a very nice looking demo. Yeah, or not demo, but interface.
Like the interface is really it's very network operation focused, right? So like a lot of people like feel at home, right? Like when they're just like, oh, okay, like I can actually see my network map, right? Because sometimes it's hard to keep all that in your head, right? We don't have the tokens. So
yes.
The cognitive tokens, we ran out of those.
That's so real, man. Cool.
Oh yeah, our Hope 9 saw it. Yeah, cool. For sure.
But yeah, so if there's let me try and find all my buttons here to get us out of here. If you have any last words or anything like that, Christian, that you want to say, or
So so we got the links there in the chat. So check those out. Definitely check out the lab. I want to say it again. If you take the lab, those watching this, if you take the lab and you get the badge, tag me on LinkedIn. I'm always on LinkedIn. And I'll be at Red Hat Summit Connect in New York. So if you're going to be there, check that out. And if not, I will be at KubeCon in Salt Lake as well. So if you want to say hi there, I'll be around, right? So just stop by, say hi. Nice.
Well, dude, thanks for coming on, man. Like hopefully if you guys have something else that you're working on that's fun and interesting to talk about, reach out to us and let us know, because we'd love to have you come back on. Like, these are to me, they're always fun conversations to have, because it's like, again, it's kind of cool being able to go back in time a little bit and like remember what it was like back in the day to work on things, and to see how you guys really made it easy, like with the packet capture thing. And I think that from one nerd to another, like it's nice to see that, and I can definitely appreciate it. So because I know how much of a pain in the butt it can be. So
no, for sure. No, I'd love to come back on. So I'll definitely keep in touch.
Yeah, right on, man. And again, so on the schedule, I think next week we're gonna go back to ground zero, but I'm not 100%. So we might get there's some things coming up in the end of the year with OpenShift and OpenShift 5 and stuff like that. So we might do something along that path as well. But I'll let you know as we get closer. But yeah, Christian, thanks a ton for coming on, man. Really appreciate your time. And stay in touch.
No, for sure. All right, bye everyone. Cheers.
Cool. See ya.